Assalamu alaikum and good evening, everyone. Today we are going to start February-March 2024, paper 4-2. Okay. So let's start with the question 1. Potassium iodide is used as a reagent in both inorganic and organic chemistry. Potassium iodide forms an ionic lattice that is soluble in water. Define enthalpy change of a solution. So the definitions, as I have told you guys, you need to remember. So it is the enthalpy change when 1 mole of a substance dissolve in water to form very dilute solution. Yeah, you can write ionic solid as well, but substance would be more appropriate, or you can write the term solute as well. Ionic solid, substance, solute. You can write anyone over here. Number 2. Potassium iodide solid has a high solubility in water. Also, its enthalpy change of solution is endothermic. Explain how this high solubility is possible. So, enthalpy change of solution is endothermic, which means it needs energy, right? But still, it has a high enthalpy, high solubility. So there would be 2 reasons. As we have discussed, that the reaction or the process tends to do in such a way that its entropy increases, right? And the other thing, that it gives free energy must be negative, because that makes the reaction or the process feasible. So it is because the change in entropy is positive and gives free energy is negative, that makes it highly soluble, and that makes the reaction of the process to be feasible. Is this understandable to all of you? Okay. Now part B. Table 1.1 gives some data about the halide ions, chloride, bromide, iodide, and their potassium salts. Okay. So that is the hydration of chloride, hydration of bromide, and hydration of iodide. And here it's the lattice energy of potassium chloride, lattice energy of potassium bromide, and lattice energy of potassium iodide. Explain the trend in enthalpy change of hydration of the halide ions. So if you see that they becomes less exothermic, right? Or you can further write less negative, and it's for 2 marks. And it is because the size gets bigger as we move down, and the attraction between the ion and the water becomes lesser, makes it less exothermic. So the enthalpy change of hydration becomes less exothermic from chloride to bromide to iodide, because the ionic radius or the ionic size increases and the charge remains same. So instead of writing this, you can write that the charge density decreases. Hence, the attraction between ion and decreases. Is this understandable to all of you? Okay. Okay, your P4 is on 6th of May or 7th of May. What is the date of paper 4? 8th of May, it's on Tuesday then. No, it's on Wednesday. Okay. Now, part 2. The enthalpy change of solution values of these potassium halides are almost constant. Okay. Use the enthalpy change of hydration and lattice in table 1.1 to suggest why. Okay. It's B part 2. Okay. Take the difference between these two. What is the difference you are getting? Tell me, please. 701 minus 364. Can anyone calculate it quickly and tell me the difference between the two values? Yes, 337. Then the second one. 335. And the third one, 336. Now, if you see, if you recall the enthalpy change expression for enthalpy change of solution, it is that enthalpy change of hydration is equals to lattice plus solution. So for a solution, the enthalpy change of hydration minus enthalpy change of lattice, this will be the expression to find the enthalpy change of solution. See, it's a minus and this is a minus over here. So minus and minus makes it positive. So minus 364 plus 701 minus 335 plus 670. Did you understand, Shoaib? Sohaib? So see that the enthalpy change of a solution is basically the difference between the hydration and the lattice energy, and that is same. And that's why we are getting almost constant. Yes, Sohaib, did you understand or not? So the difference between enthalpy change of hydrogen and that is almost constant because we have seen 337, 335, 336. Hence, the enthalpy change of solution are almost constant. Is this clear to all of you? Now, third part. Yeah. The enthalpy change of solution of potassium iodide is positive 21 kilojoule per mole. Use this information and the data in table 1.1 to calculate the enthalpy change of hydration of a potassium ion. Okay, so if you recall the expression as I have told you, that the sum of enthalpy change of hydration is equals to lattice energy plus enthalpy change of solution. So why sum of hydration? Because hydration is specific for every gaseous sign, right? Give me a minute, please. Okay, so we have to find the hydration of potassium plus hydration of iodide, because here we have iodide ion and the hydration of iodide is given over here minus 293. So plus minus 293 is equals to lattice energy of potassium iodide is minus 629 plus enthalpy change of solution is positive 21. So the enthalpy change of hydration of potassium is minus 629 plus 21 plus minus minus and minus when we move it to other side, it becomes plus 293. You will solve it and tell me the answer, please. It's minus 315 kilojoule per mole. Is this understandable to all of? Okay. Now, part 4. Solid lead iodide forms when potassium iodide is mixed with potassium with lead aqueous. The solubility product of PbI2 is 7.1 exponent minus 9 mole P cube dm minus 9 inverse 9. Calculate the solubility of PbI2. So the solubility of PbI2 means that it's going to form lead ions in the aqueous state and 2 moles of iodide ion in the aqueous state. So X moles of this would form and 2x moles of this would form. So the solubility of lead iodide is basically the X, because if you see the mole ratio between the lead iodide and the lead ion is 1:1. Yes, Mehbeen, it's not 293, it's minus 315 over here. And you are asking positive 293. It comes from, it is the hydration of a iodide ion, which is given over here in the table. Okay. Okay. So we have a KSP. Okay. If you look at the equation of the dissociation, and from that, if you write the KSP expression, so the KSP expression would be equals to concentration of lead ions times concentration of iodide ions square. Okay. We know the KSP value, which is 7.1 exponent minus 9. The concentration of lead ion is X, and the concentration of iodide ion is 2x. And in this expression, we have a square. So if we solve it, it will become 7.1 exponent minus 9, 4 x cube. And if I have to find the x, so x is equals to cube root 7.1 exponent minus 9 over 4. Now, can anyone calculate the value and tell me the answer, please? Okay, so it is 1.21 exponent minus 3 mole per dm3. Is this understandable to all of you? Okay. Now part 5. The ionic radius of lead is 0.012 nanometer compared to 0.13 nanometer of potassium. Suggest how the lattice energy of lead iodide differs from the lattice energy of potassium iodide. So if you see that the lead has a smaller radius and a bigger charge, right? Smaller radius and bigger charge. So as a result, lead ion has a higher or greater charge density, right? So the attraction of a lead ion with the iodide ion would be stronger than the potassium ion and the iodide ion, and hence if it's stronger, then it means a stronger bond would form, and as a result, the more energy would release. So the lattice energy would be more negative. So I will write over here that lead to positive ion has greater charge and a smaller size than potassium ion, hence stronger attraction between lead ions and iodide ions. So the lattice energy is the energy when the gaseous ions forms a ionic solid. Yeah, you can write that greater nuclear attraction as well. A stronger nuclear attraction between but the nuclear attraction is for the lead ion only. Okay, so the lattice energy is more exothermic because the more stronger the bond form, the more energy it will release. Is this clear to all of you? Okay. Now, C part. Potassium iodide slowly oxidizes in air, forming iodine. Okay. Here we got the equation. They have given you the enthalpy change. They have given you the entropy values. Calculate the standard entropy change of a reaction 1. Okay. So change in entropy is basically the entropy of the product minus entropy of the reactant, right? So change in entropy would be sum of entropy of product minus sum of entropy of reactant. Okay. So in product, we have iodine and we have a 2 moles, so we have to times it 2. We have K2CO3 and its 2 moles are also there, so we have to times it 2. So these are the products, right? And the rest of the 3 are reactants. This one, and this one. And carbon dioxide, there are 2 moles, so I have to make it times 2. Oxygen has a 1 mole, so potassium iodide has a 4 moles and it's potassium iodide, so it's times 4 and oxygen would be times 1. Is this clear? No, it's a change. So change is always product minus reactant. Okay, so let's start with the products. So we have a one product, 2 times 155.5. Then we have the other product, 2 times 116.1. That is the sum of the entropy of the product minus sum of the entropy of the reactants. So one reactant 4 times 106.3. The other reactant is 205.2. And the third reactant is 2 times 213.6. Please check again your answer, Mehvi. Yes, Abdullah. I'm multiplying it with the number of moles. Yes, Manam, very good. It's minus 514.4. Yeah. Yes, I will upload the recordings today, inshallah. Use your answer to C1 to show the reaction one is spontaneous at 298 Kelvin. Okay, so spontaneity means we have to use the Gibbs free energy expression, and they are saying that C1. So C1 is basically change in entropy. So the Gibbs free energy expression is delta H minus T delta S, right? So the delta H is given over here, minus 203.4 kilojoule. So minus 203.4 kilojoule minus temperature, they have mentioned 298 Kelvin times entropy. This entropy is in joule. So I have to multiply, divide it with 1000 to turn into a kilojoule. Because this one is in kilojoule and Gibbs free energy is also in a kilojoule. So can anyone calculate it and tell me the answer? Okay, Maham. So it's 50.108. So minus 50.108. So it is going to be 50.1 kilojoule per mole. So see that it's negative, which shows that it's spontaneous. Okay, now third part. Group 1 carbonates are much more thermally stable than group 2 carbonates. Standard explain the trend in thermal stability of group 2 carbonates, and it's of 2 marks. Okay, so it increases down group 2 because the cationic size of group 2 increases, causing less ion polarization of carbon, making carbon oxygen bond stronger. Is this clear to all of you? Good. Now D part. The student electrolyzes a solution of aqueous potassium iodide for 8 minutes using a direct current. The half equation for the reaction that occurs at the anode is given. Write a half equation for the reaction that occurs at cathode. Okay. Aqueous potassium iodide. So At cathode, cations would be attracted, and there is a potassium ion and a hydrogen ion because it's aqueous. So yes, now you can see Mahaveen. Yeah, that can be also fine. And Sharia electron cloud distortion, not dissociation. Okay. If you write electron cloud distortion, then it is fine, not dissociation. Okay. So there are potassium ion and a hydrogen ion. And we know at cathode reduction occur the ion which is lower in the reactivity series reduces first. So hydrogen is below potassium in reactivity series. So hydrogen ion will reduce and form hydrogens. And we know hydrogen as a gas exists as a diatomic. So it means there must be two hydrogen ions and each hydrogen ion gain one electron. So total of two electrons must be gained. Is this clear? And it must be aqueous and it must be gassy, include state symbols. Okay. Now, after the aqueous iodine produced required 21 centimeter cube of 21.35 centimeter cube of 0.100 mole per dm cube sodium thiosulfate to react complete. Calculate the average current used in 8 minutes during the electrolysis. Okay. So this is the volume and this is the concentration of this substance. Okay. So from this, what I can do, can I able to calculate the moles of sodium thiosulfate? Because why I am calculating the moles of sodium thiosulfate? Because I am given with the concentration and volume of thiosulfate only. So the concentration of thiosulfate is 0.100 and its volume is 21.35, which is in centimeter cube. So I have to divide it with the 1000 to turn into decimeter cube. Can anyone tell me the moles of thiosulfate? Okay, Maha. These are 0.002135. So these are the moles of thiosulfate. If you see the ratio, so ratio will help me to identify that if I have to find the moles of iodine, for 2 moles of thiosulfate, we need 1 mole of iodine. So moles of iodine is basically equals to moles of thiosulfate divided by 2, isn't it? So 0.002135 divided by 2 will give me the moles of iodine. Is this understandable to all of you? So if I divide it, can anyone tell me the answer, please? Okay, Abdullah. See the ratio. Instead of dividing, you can make the ratio. Sodium thiosulfate and iodine. There are 2 moles of sodium thiosulfate and 1 mole of iodine. So if the moles of sodium thiosulfate are to this, then this would be X. Now, see, it's 0.002135 over 2 multiplied by 1. So it's the same thing, isn't it? Okay, it's 1.0675. Thank you, Mohammed Shahar. 1.0675 exponent minus 3. So we got the moles of iodine. Okay, we know the time, right? Okay, now let's make the equation for the electrolysis the formation of iodine, if you recall that equation, the equation wouldn't be like this. 2 moles of iodide gaining 2 moles of electron, forming 1 mole of iodine. Is this understandable? Yes, that is the electrolysis equation. See that after the electrolysis, the iodine produced. So the iodine is produced in the electrolysis by this equation. Is this understandable to all of you? And we know that there the time is 8 minutes, right? Okay. Now see, from this equation, what I can conclude that 2 moles of electron means 2 Faraday, which means 2 times 96500 coulomb is forming 1 mole of iodine. Is this understandable? So, if these moles of iodine are formed, then how much coulomb of charge is passed x? So let's calculate the value of x. X is the coulomb when 1.605 exponent minus 3 moles are formed. So 2 times 96500 times 1.0675 exponent minus 3 divided by 1. Can anyone tell me the value, please? Okay, after 206, do we have some other figure? Okay, 206.2. Thank you, Mahmeen and Maham. So that's the coulomb. And we know coulomb is the electric charge, that is Q, and its formula is Q is equals to current times T. So if I have to find the current, so current is equals to Q over T. So Q is a coulomb, which is 206.2, and time is 8 minutes, which must be converted into seconds by multiplying it 60. So now solve it, we will be able to find the current in amperes. Is this understandable? Can anyone calculate it and tell me the answer, please? That is the first thing, that is the second thing, that is the third, fourth, and fifth. Okay, it's 0.4292. But it's 0.429. That's fine. 0.429 amperes. Thank you, Mohammed and Mahmoud. Till here, is this clear to all of you? If any one of you has any confusion, please ask. Okay. Now, E part. Potassium iodide is used as a source of iodide in organic synthesis. One example is of this is shown in synthetic route in figure 1.1. Okay. So if I work here, I got concentrated nitric acid, concentrated sulfuric acid, and 55 degrees Celsius boiling temperature. In step 2, tin and concentrated hydrochloric acid. It's electrophilic substitution and it's a reduction. In step 3, it's diazonium ion formation, right? Where the temperature condition is equal to or lower than 10 degrees Celsius. Okay. And then in D, if you see, it's a nucleophilic substitution in step 4. And that is a diazotization reaction, step 3. Yes, we need to heat as well. Very good, ma'am. Okay, identify the reagents required for step 1 and step 2. So for step 1, we required, as we have discussed, concentrated nitric acid and concentrated sulfuric acid. Now, step 2. In step 2, tin and concentrated hydrochloric acid. They didn't ask for the conditions, right? So there is no need to mention any temperature conditions or heating or pressure conditions. Okay, now part 2. Step 3 occurs in 2 stages. Okay, yeah, that's what we have discussed in the lectures, and you will find the equation as well, that NaNO2 and HCl reacts to form HNO2, and that HNO2 is reacts with phenylamine to form diazoniamine. Complete the equation 1 for stage 1 and then stage 2 in stage 1. If you recall, HNO2 will form and NaCl. And here it's a phenylamine, a benzene ring bonded with NH2. And they are asking for the equation. Okay, this HNO2 reacts in the acidic condition. There is a one nitrogen over there. We got the diazoniamine, so you will just make this as the product C6H5N2 positive. And beside this, water are formed. And if you count 2, 1, 3, 4, 3, and 4, 4 hydrogens, so you will put 2 over here to balance it. Is this understandable to all of you? Now, third part. See, question number 1, only 26 marks. The iodide from potassium iodide reacts in step D in step 4. The mechanism is shown in figure 1.1. So just the name of the mechanism. So see, we have already decided SN. SN means nucleophilic substitution. So the mechanism would be nucleophilic substitution. Is clear to all of you? Okay. Now question number 2. Water is an amphoteric compound that act as a good solvent of a polar and ionic compounds. Amphoteric means it is act as a being acidic, acid and a base as well. Question will show water acting as a prostaglandin acid. Identify 2 conjugate acid base pairs in equation 1. If you see water, water turns into OH. And how water turns into OH? By losing its hydrogen. So water is an acid, so its conjugate base would be OH minus. Is this understandable? Okay, Mariam, why not? What is electrophile? Can you define me an electrophile, what it is? Electrophile is the one which is electron deficient, and nucleophile is the one which is electron rich, and the nucleophile is the one which contains a lone pair. So if you see that this iodine has a lone pair, and from this lone pair it is attacking over here, and then we are observing that iodine gets its position over here, right? So it means it's a nucleophile. And if nucleophile is replacing someone, so it means the thing that is replaced is also a nucleophile. So that's why we call it nucleophilic substitution. Is it clear, Mariam? Okay. So here the conjugate base of water is OH minus. Is this clear to all of you? Okay. Now, if you see this word turning into HNO2 by accepting the hydrogen ion. So this one is accepting the hydrogen ion. So it means it's a Bronsted-Lowry base. So I'm going to write NO2 negative over here, and HNO2 would be acid. Is this clear? Okay. Now, part A2. Water also behaves as a Bronsted-Lowry acid when it dissolves in methylamine. Explain the ability of methylamine to act as a base. Yes. No, it has a lone pair. The nitrogen has a lone pair, and by the lone pair, it has a ability to accept the proton, the H positive ion. That's why it acts as a base. So I will write that nitrogen in methylamine has a lone pair by which it accepts hydrogen ion. Is this understandable to all of you? Now part 3, write an equation to show water acting as a base with CH3COOH. If water is acting as a base, so it means water is going to lose the H positive or accept the H positive. Yes, if water, it accepts the H positive, right? So then acid CH3COOH is going to lose the H positive. So when it loses the H positive, it becomes the negatively charged, and that H positive is accepted by water. As a result, water becomes H3O positive. Is this clear? Okay. Now, the ionic product of water, Kw, measures the extent to which water dissociates. Okay, we have an equation of the dissociation of a water. Figure 2.1 shows how Kw varies with the temperature. So if you see that the temperature is increasing, the Kw value exponent minus 14. Okay, it's increasing, right? Write an expression for Kw. So I hope everyone remember the expression for Kw, that Kw is equals to concentration of hydrogen ions times concentration of hydroxide ions. Is this clear? Okay. Number 2, use information figure 2.1 to deduce whether the dissociation of water is an exothermic process or endothermic process. So if you see, as the temperature increases, the more Kw value will be, the more dissociation occurs. So is it exothermic or endothermic? Endo. And how you will explain this? Yes, very good. It's Abdullah and yeah, it's endo. Because as the temperature gets higher, the Kw value getting stronger increases. It means there are more hydrogen and more hydroxide ions at higher temperature. So if there are more hydrogen and hydroxide ions at the higher temperature, so we can say that as the temperature increases, equilibrium shifts towards the right, which means that the forward reaction is endothermic. Is this understandable? It's endothermic because equilibrium position moves to right on increasing temperature. Is this clear to all of you? Okay. An aqueous solution has a pH 7 at 30 degrees Celsius. Use information figure 2.1 explain why this solution can be considered to be alkaline at 30 degrees Celsius. Yes. Can anyone explain this? Let me show you. At 30 degrees Celsius, if you see, oh, can we say that at 30 degrees Celsius the Kw value is not, it's around 1.5 exponent minus 14. Maybe it's the pH 7 is neutral only at when the temperature is 25 degrees Celsius. That's what I've always mentioned in the notes. That I've always tell you that the pH and the concentrations are always a temperature dependent. That when we say that the pH 7 is neutral and the acid is a one which has a pH lower than 7 and the base is the one which is pH as a higher than 7, that's what we are talking about at temperature 25 degrees Celsius. Now see at 30 degrees Celsius, isn't it? Kw value is 1.5 exponent minus 14. Right? Is this understandable to all of you? And at 25 degrees Celsius, if you see over here, it's 25. At 25, we have a value of 1 exponent minus 7. Right? So now let's look over here. At 25 degrees Celsius, Kw is 1.00 exponent minus 14. And at 30 degrees Celsius, Kw is 1.50 exponent minus 14. That's what we have concluded from the graph. Is this understandable? Now see, we know that Kw is concentration of hydrogen ions times concentration of hydroxide ions, right? Now, at 30 degrees Celsius, Kw is 1.50 exponent minus 14. And can I write it like this? Because we know that it's a pure water. So then the hydrogen ions and the hydroxide ions concentrations are equivalent. So for a pure water, if you find that concentration of hydrogen ion, isn't it equals to 1.50 square root of 1.50 exponent minus 14. So can anyone calculate the value of hydrogen ions? Yes, can anyone calculate the value and tell me the answer, please? It is 1.22 exponent minus 7. So these are the concentration of hydrogen ions. So if I will find the pH of hydrogen ion in the pure water, it is going to be minus log 1.22 exponent minus 7, isn't it? Can anyone calculate the pH and tell me the answer? It's 6.91. So see, that is the neutral pH now. at 30 degrees Celsius. Hence, pH 7 is alkaline at 30 degrees Celsius. Is this understandable? That is for 25 degrees Celsius, Abdullah. If you work for from this, because it's for 25 degrees Celsius, you will get the pH 7. And at 25 degrees Celsius, OH ions and H ions are equal at pH 7. But at 30 degrees Celsius, the hydrogen ion concentration and the hydroxide ion concentration gets equal at this pH. So it means that this pH is neutral now at 30 degrees Celsius. So the any number of any value of pH higher than this would be yes or no, it's not necessary. Only if you see, if your answer in these lines, then it is always checked. Your answer must not move out of these lines. Okay. So any confusion till here? Now see part. The three physical states of water have a different standard entropies associated with them. Table 2.1 shows the entropy values. Okay. So it means ice has this entropy. Liquid means water has this entropy, and gas means steam has this entropy. I hope it's understandable to all of you. Explain the difference in entropy values of water, solid water, and a liquid water. Okay. So I will write that H2O liquid has more disorder between its molecules, isn't it? Then explain why the increase in entropy is much greater than water boils when it melts. Okay. It is because in a steam, when it becomes gas, there are so many more ways of arranging particles. But when it melts, it just turns into liquid. The ways of arrangement of particles in a liquid is limited, but the ways of arranging the particles in a gas are way more. So that's why the increase in entropy is much greater. Is this clear? Yes, Abdullah, what's the confusion? See, let me recall. When the solid melts, in solid the particles are just vibrating. Yes, but you will write that the disorder is way more, not just more, it is much more. Because when the liquid turned into gas, and gas, the particles move freely and randomly, and that much free movement and randomness, it's not present in the liquid. Okay. The energy change for solid to liquid water are shown. Okay, it's a Gibbs free energy and it's an enthalpy change. Use the data to show how the melting point of water is 0 degrees Celsius. Okay. So the entropy of a solid is 48 joules, and the entropy of liquid is 70.1 joules. So the entropy change would be 70.1 minus 48. Can anyone calculate the entropy change? Yes, but not just more disorder you will write, having there is much more disorder when in the gas. Okay, so we got the entropy change 21.9 joules, and these are kilojoules. So to turn them into joules, you have to times it 1000, so it's going to be 0. And turn into 1000 times 1000, it will going to be 6030. Okay, so what is the Gibbs free energy expression? Gibbs free energy expression is equals to delta H minus T delta S, right? So you have to show that temperature is 0 degrees Celsius. So we have to make the temperature subject, right? So what I can do that Gibbs free energy plus T delta S is equals to delta H, and T delta S is equals to delta H minus delta G, and temperature is equals to delta H minus delta G over change in entropy. Is this understandable? I'm not sure you can calculate it. 70 minus 50 is going to be 20. 70.1 and 48. 70.1 minus 48. It's 22.1. Sorry. So the entropy change is 22.1. Okay. What I did with the expression, is this understandable to all of you? Okay. Now we have turned everything into joules, right? So the delta H is, it's 6030 minus 0 over 22.1. It's 272.85. So the temperature we got over here is, it's Kelvin, right? And if you recall, this, isn't it, this equals to 0 degrees Celsius? Yeah, you can do that as well. But no, because the entropy change, yeah, you can do it either way. That's fine. So it's around 0 degrees Celsius, isn't it? So we have proved that the temperature where it melts is 0 degrees Celsius. Yes. Till here, is it clear to all of you? Okay. Now D. Metal air batteries are electrochemical cells that generate electrical energy from the reaction of metal anodes with air. The standard electrode potential for zinc air battery are shown. Okay. If you see, this value is smaller and this one is greater, so it means its reduction occur and here oxidation occur. To make the net equation, we have to flip this equation. If we have to make the net equation, then calculate the cell potential. So for the cell potential, if you recall the formula, E naught cell is equals to E naught of a half cell where reduction occurring minus E naught of a half cell where oxidation occurring. So we have identified where the oxidation and the reduction occurring. So 0.40 minus 1.22. Okay, there is a minus sign with that. So minus 1.22. So it is going to be minus minus plus plus 1. So the sign it would be plus 1.62. Is this clear to all of you? Mehveen, it's 272 Kelvin. So that is always equals to 0 degrees Celsius. Because if you see, when we have to convert the Kelvin, we add 273 in a Kelvin. When you have to make the net equation, if the examiner asks you to make the net equation from these two half equations, so the equation where the oxidation is taking place, see, the electron is on the left side. So here it shows the forward direction is reduction. So whenever you have to make the net equation, you have to flip this equation if it's written in form of reduction. Otherwise, if it's written in the form of oxidation, you will keep it as it is. Okay. Till here, is this clear? Now, the zinc-air battery usually operates at pH 11 and 298 Kelvin. The overall cell potential depends upon hydroxide ion concentration. The next equation shows how the electrode potential at the cathode changes with the concentration of hydroxide ion concentration. Calculate the electrode potential E at pH 11. Okay. So we don't know the hydroxide ion concentration, but we are given with the pH value. So, and the temperature is 298 Kelvin, which is 25 degrees Celsius, right? And at 25 degrees Celsius, we know that the Kw value is equals to 1 exponent minus 14. So, and pH 11. So from the pH 11, can I able to find the concentration of hydroxide ion exponent minus 11? No, sorry. I am able to find the concentration of hydrogen ions. Yes. So it is going to be 1 exponent minus 11 is the concentration of hydrogen ion. And if I have to find the concentration of hydroxide ion, it's equals to Kw divided by concentration of hydrogen ion. Kw is 1 exponent minus 14 and hydrogen ions concentration is 1 exponent minus 11. When you solve it, you will get the OH ion concentration is 1 exponent minus 3. Is this clear? Now we will put the value over here. E is equals to 0.40 minus 0.059 over Z. Z is the number of the electrons in the half equation. So here we have the number of electrons 2. So I'm going to put 2 over here. Log 1 exponent minus 3 squared. Can anyone solve it and tell me the answer, please? Okay, thank you, Sean. It is 0.577 volt. So that is the answer. 13 marks. So two questions, 26 and 13, 39, almost 40%. Okay. So we are keeping our class till here. Tomorrow we will continue this paper from here onwards. Okay. Yeah, cathode is where oxidation occurs and anode is where no cathode is where reduction occurs. I don't think in this paper we have a okay. Take care, everyone. Allah Hafiz.